Okay. Yan. So, okay. So, wala ba kayong mga access sa ano natin? So, you just need to create an access website. So, just go to the student portal ng Terahertz. Okay. So, punta kayo sa Terahertz. Ito. No? Ito yung link natin. Okay. So, punta kayo dyan and then view nyo itong Open Run. Okay. So when you view the Open Run, you can see all the the recorded sessions. Ito yung session 1, nandito yung recorded session natin. Session ito yung session 2. Session 2, session 3, and then session 4. Open Run use cases. Hindi pa yata na-upload yung mga learning activity, no? Dun sa session 2 and session 3. Teka, sasabihan ko na lang si yung mga speakers natin to give me the data para ma-upload natin. Okay? So punta lang kayo dyan, no? Ayan. Pero yung mga recorded session, nandiyan yung mga recorded sessions. Nung dalawa, nung deep dive, ito yung deep dive, and yung run intelligent controller. Wala lang yung mga learning activities, no? Okay? Yung learning. Yep. Yes, this one. Ito yung Run Intelligent Controller. So later on, siguro bukas, we'll upload the Open Run use cases. And what do you call this? The access is only valid until December 10. Kasi this is just a workaround, no? Ginamit lang namin yung website ni Terahertz just to give you some time to review yung mga recorded sessions. Typical kasi we need to use yung Rakuten's learning management system. Since hindi pa siya ganong available, so we just use the workaround. So the access would only last until December 10. Yan. So access nyo na siya. Okay, so let's continue our discussion about the different use cases. Okay, so before we continue the use cases, let's let's have a quick review of the ORAN Alliance. Okay, so the ORAN Alliance, which was formed in February 2018. So this for goal of promoting the open and intelligent RAN. So this is the second organization driving the Open RAN movement and was created by merging of two organizations. So meron tayong China Mobile, the CRAN Alliance, and the XRAN, which is composed of the entity Docomo. So the founding operators are si AT&T ng US, si China Mobile ng China, si Deutsche Telekom ng Germany, si NTT Docomo ng Japan, and si Orange ng France. Okay? Hindi siya downloadable, no? Yan. Okay. Okay, so ORAN Alliance. So this is a group of telecom companies. So it is just like the 3GPP, no, but focusing on the Open RAN system for the specifications. Okay. So ito yung ating mga technical work groups and architecture. So meron tayong SMO. Nandiyan sa SMO, nandiyan si RAN Intelligent Controller, non-real time. So any task that is greater than 1 second, it belongs to the non-real time. Okay? So lahat ng mga policies, yan, yung mga analysis, pag-check, pag-develop ng mga policies with the help of AI and machine learning, dito ginagawa. Okay? Mga configurations, inventory, and designs, dito rin. And then after that, bababa niya yung policy, papunta kay near real-time RIC sa RAN Intelligent Controller. So these are the applications less than 1 second. Okay, so kunyari lahat ng mga sasabihin ni SMO, all voice calls must go to low band. Ganun yung mga types of policies, no? All data connections or mobile broadband go to high band. Ganun yung mga policies na binababa kay near real-time rate. And then si near real-time rate, it is powered by third-party app. We call it the X app. Okay, and then the X app has a different functionalities, like for example, radio connection management, mobility management, QoS, interference, and train model. And the X app is also configured like the traffic steering X app, the massive MIMO XApp. Okay, so that's where this third-party XApp becomes more important. Okay? And then kapag na-analyze na nila yan, and also with the use of artificial intelligence and machine learning, it will command, no? It will give the instructions to the CU, the CUCP and the CUUP na baguhin yung parameter. Okay? Yung mga threshold na pinapag-usapan natin kanina. Okay? And then it's either from the CUCP or CUUP, it can go to the ODU, okay, or RLC MAC physical layer. Okay, so change parameter. So ganun, kaya ang application nito is less than 1 second. Dapat mabilis ang implementation. Okay, so dito nangyayari yung mga parameters. So binabago natin yung mga thresholds, parameters, okay, para at least ma-achieve natin kung ano yung gustong mangyari ni SMO. Okay, ayan, ito yung overall architecture niyan. And then of course yung mga lower physical layers natin sa ORU. So ito yung simplified version. So the simplified version is SMO, near real time, andyan yung XApp, okay, OCU, and then the ODU, ORU, and then the OCloud, yung physical infrastructure kung saan nag-host itong mga to. And last week, you learned that the implementation of the ORAN architecture might be different from different vendors, di ba? So it depends on them. So nung nag-ano si Mavenir, they have a different setup para dun sa ORAN implementation, and then kay ano naman kay parallel wireless, it is for example yung RAN intelligent controller is embedded dun sa kanyang aggregator. Okay? So it depends on sa ano. Kaya kinakailangan meron kayong yung multi-vendor, and then interoperability is important dito sa Open RAN. Okay, so using the ORAN architecture has the following benefits. So the ORAN is capable of reducing network capex and opex. Okay, and the ORAN is capable of improving network efficiency and performance. And the ORAN is capable of importing new capability and with great agility. Okay. So si ORAN Alliance has introduced key use cases, and it is subdivided into 2 phases. Okay. First is the phase 1 and phase 2. So phase 1 is the basic implementation, the fundamental use cases. Like for example, the use of low-cost RAN white box hardware. So this is the use of ODU and ORU. Next, the traffic steering. Okay, we will tackle this later on. The QoE, the quality of experience optimization, the massive MIMO optimization, and the quality of service-based resource optimization. So this is the phase 1. Okay, so when you check some applications of the Open RAN in some adapters, so the phase 1 is the mostly implemented. Phase 2 is the advanced implementation. It includes the RAN sharing, RAN slice, service level assurance, context-based dynamic handover management for the V2X. So this is for the automated vehicle, right? And you also have the flight path-based dynamic UAV, the unmanned aerial vehicle resource allocation. And also there is a radio resource allocation for UAV applications. Okay, so later on we will tackle, I think, one of these 2, and the RAN sharing and the massive MIMO. Okay. Okay, so so when you look at when we go deeper on the different phases, you can also see the different impacted network elements, no? Like for example, the traffic steering, the interfaces involved is the O1, A1, and the E2. Why? Because these are the interfaces interconnecting these components like non-real-time RIC, near real-time RIC, and the OCU. Okay, so it's just like the summary of the use cases details. Okay, and what are the elements and the interfaces involved in implementing this ORAN Alliance use cases. Okay. Let's start with traffic steering. Yan. So traffic steering. So when we talk about traffic steering meaning meron tong katumbasan sa current setup natin load balancing. Okay, load balancing. Just imagine merong barko, no? Meron tayong ship. So typical kapag sumasakay kayo sa bangka na lang, sa bangka. What typically you do, no? Kapag sumasakay kayo ng bangka, lahat ba kayo nakaupo sa kaliwa? O lahat kayo nakaupo sa kanan? What you typically do? Yung mga mabibigat nasaan? Yung mga magagaan nasaan? Anong typical ang ginagawa niyo kapag sumasakay kayo sa bangka, sa balsa, no, na may possibility lumubog, no, dahil sa dami ng tao na nakasakay? You typically do, ano, di ba? Yan, sa gitna. And then kung tinitingnan mo rin, di ba, sa mga advanced level, yan, no, sa center. Tapos sa side, depende, no, left and right, yan. Binabalance nyo yung weight. Yan, correct, no? So typical, kapag binabalance nyo yung weight, anong ginagawa natin? So ina-analyze natin, no, yung physical physical structure, physical appearance, no, nung nakasama natin sa bangka. Kapag medyo tingin natin, no, na medyo yung kanyang impact sa gravity is medyo mataas. Okay? Lalagay natin siya sa kanan, no? Ayan. Tapos yung mga may less impact sa gravity, less impacted by gravity, yan, nasa kanan sila, nasa kaliwa. And then sometimes we combine them, no? We mix them. So para maging balance yung ating bangka. So traffic steering is something like that, no? Yan. So binabalance natin yan, yung ating network to achieve a certain certain target sa ating network. Okay? So like for example, the traffic steering, when you say TS, no, traffic steering, directs traffic to specific cell. So we are pushing the traffic, okay, to some cell. Like for example, dun sa pinakita ko sa inyo kanina, okay, this one, no? Sa typical, kaya natin ginamit ito kanina, no? So take a look at this, no? May mga cells, may mga areas. Can you see the screen? May mga areas tayo na maraming maraming tao. And then there are areas na katulad dito, wala namang ganong tao dito, no? Yan. So it depends, no, kasi yung ating network is dynamic. Hindi yan static, no? Nagbabago yan. So every now and then yung ating traffic is changing, yung behavior ng subscribers natin is changing. Suddenly merong na-aksidente sa area, they would like to upload it in the Facebook instead na tulungan yung na-aksidente. They would rather choose to take a video of that accident and then consume the resources of the network. Okay. So there should be a traffic steering strategy that we need to do, no? Yeah. So because the distribution of subscribers is dynamic, okay, the subscribers are moving and the subscribers behavior is changing. Okay, so we need to have a traffic steering strategy. So okay, so we have a challenge. So the typical traffic steering mechanism is the use, we are currently using the radio conditions of a cell by treating all UEs or user equipment, yung mga telepono, in the same way with the average values. So ito yung typical mechanism natin. And these are limited to adjusting, like for example, yung cell reselection, handover parameters, and then cell priorities. So cell reselection, kapag yung signal level is ng isang cell site is mas mataas sa kabila, so magse-select siya doon, pupunta siya sa kabila, no, kung saan mas mataas. Okay, cell reselection. And handover parameters, so there is a threshold. Like for example, meron na silang difference ng signal level. Signal level nito is mas mahina ng certain dB at something here. And then Meron tayong timer, katulad ng pinakita ko kanina, and then it will perform yung handover. Meron naman tayong mga cell priorities. Like for example, priority 1 is yung mga LTE subscribers will go to the LTE, and then next LTE 700, like for example, and then next priority will be L2100, and then next priority will be L21 3500. So pwedeng gano'n, no? Yung mga cell priorities natin. So ang ating objective is to customization. We would like to customize of the UE-centric strategies and proactively optimize by predicting network conditions. Okay, so you can see the word predicting the network conditions. So the machine learning to control the adaptation of diverse scenarios and objectives. And it will also allow operators to specify different objectives of for traffic management. So by optimizing the network, UE performance, and achieving balanced cell load and others. So it also allows operators to flexibly configure the desired optimization policies. Like for example, utilize the right performance criteria, leverage the machine learning to enable intelligent and proactive traffic steering control. So it depends sa operator. Makokontrol nila yan using the X app. Mamaya pakita ko kayo ng sample ng X app. And then there's the required data. Okay, so measurement reports, we need to have the RSRP, the signal level, the reference signal receive power, or the RSRQ, the reference signal receive quality, or the channel quality indicator, yeah, the serving of neighbor cell, kinakailangan yan para ma-analyze ng ating mga artificial intelligence, cell quality thresholds, measurement gaps on per UE or layer or frequency basis. We also have the connectivity and mobility handover statistics of indicating yung mga successful handover or failed handover. So pag sinabi natin successful handover, no, like for example, nag-drive ka, papunta ka sa kabilang papunta ka sa kabilang cell site. Okay, nag-drive ka dito, papunta ka sa kabilang cell site. Kapag ka yung tawag is hindi naputol, successful handover yon. Okay, meaning the network is able to transfer you from this cell going to this cell. So successful handover yon. Kapag ikaw ay nag-drop, failed handover. Okay, so mabibilang ka sa mga failed handover. So ginagamit ng system yan, yung mga parameters na yan, to feed yung ating artificial intelligence machine learning para sa ma-feed niya kay non-real-time RIC, no, na makapagbigay ng magandang decision or policy. Okay? And also you can see the UE performance statistics. Like for example, yung PDCP throughput, okay? RLC and MAC latency, no? Para makita niyo yung performance. Bumabagal na ba yung mga throughput ng mga UE na to? Okay? So like for example dito, no? Saan na 'yon? Okay? Dito, no? So kinakailangan niya makita to. Ayan, yung mga PDCP throughput na yan. So once na in-input natin yan sa artificial intelligence / machine learning ng non-real-time RIC or near real-time RIC, gagamitin nila yan for creating a policy. Okay? So dynamically, pwede yung utusan ng magbabase non-real-time RIC ng policy papunta kay near real-time RIC, and then sabihin ni near real-time RIC, palitan ng mga parameters, we need to achieve this kind of target. Okay? So ganun siya naka-dynamic. So kapag bumabagal na yung throughput ng PDCP throughput, like for example sa mga cells na to, kinakailangan yata natin silang ilipat sa kabilang cell. So that's the main purpose ng traffic steering. So ganun siya ka-dynamic and ka-intelligent, no? So kapag gumagamit tayo ng traffic steering use case using the ORAN alliance na architecture. Okay? So what happens is like this, no? Sa traffic steering use case, no? Yung mga node responsibilities. Like for example, si SMO and si non-real-time RIC, it defines and updates the policies. So it guides the traffic steering. Like for example, meron tayong traffic steering app, X app, in the near real-time RIC, no? Like for example, yung optimization objectives to guide the carrier or band preference ng UE. So there is a setup naman na lahat ng mga UE would go to this certain frequency and then another frequency papunta na other set of UEs papunta naman sa kabilang frequency. So, pwedeng ganung strategy ang gamitin niya. And it also performs the statistical analysis. Yeah, so to provide yung mga enrichment information for the non-real-time rig to assist para sa traffic steering function. Meron din tayong, this is the one that also communicates the policies and enrichment information. Yan, measurement papunta kay near real-time rig. So the policy, the A1 policy, enrichment information. So these are the declarative policies, no, to enable the non-real-time rig to guide. Like for example, all voice calls must go to low band. Yeah, so yung mga types of A1 policies. And all broadband connections must go to high band. Yan. So meron tayong mga A1 policies. And then A1 enrichment information, additional info yan used by the near real-time rig collocated at SMO, non-real-time rig, from non-network data or from network functions. Okay. And then si near real-time rig, this is the one who interprets kung ano inutos na policy ng SMO. Okay. From non-real-time rig, and also uses yung enrichment information. Okay, so it's either yung RF fingerprint to predict the inter-frequency cell measurement. So yung RF fingerprint is nagbibigay yung mga UE natin ng mga cell ID, okay, cell information, signal level, RSRP. Ano yung RSRP ng current cell, ano yung signal level sa neighbor, ano yung signal level sa kabilang neighbor. So the AI and the ML can easily predict saan papunta yung isang cell, and ano yung gagawin niyang parameter changing or parameter modification. So yun yung gamit ng mga enrichment information like the RF fingerprinting. And then after that, it will send the control messages pababa sa mga E2 nodes. So the E2 nodes could be the OCU UP, OCU CP, or ODU. Okay, so sa distributed unit. Ito yung mga E2 nodes natin or yung EOE node B kung LTE. Okay, so it collects and transmits data with required granularity to SMO over O1 and then executes action. Okay, so when we look at the example, like for example kay Remedo, ganito yung itsura niya. Ito yung mga policy. Yan, ganyan. So naka-JSON siya, JSON format. So mga readable JSON format. Okay, JavaScript. Okay. So andito yung description. Okay, so ORAN standard traffic steering preference policy, ano yung type niya or object. Okay. So you can see here yung mga policy relate to, like for example, single or group UE ID, slice ID, QoS ID, or cell ID. So niyan, andito nakalagay yung mga data types. So kaninong UE ID to, anong slice ID, like for example, slice 1, slice 2, slice 3, i-deploy itong policy na to. Okay? And then you also have this user type or object type number. So you have the cell ID, okay, number, or QoS ID, and then cell ID number. Okay? And then in the policy as well, you can also select yung mga restrictions or mga preferences sa cells. Like for example, this cell this UE shall go to this cell. Yan. Or preferred to this cell, pupunta siya sa ganung cell. Or avoid this cell. So ibig sabihin yung mga UE na yun, hindi sila pupunta dito sa cell na yan at this point in time or this certain scenario. Okay? Or forbid. They will not forever go there, kung as long as effective yung policy. So meron ganyan mga types of implementation procedure. So like for example ito sa traffic steering per UE. So the UE ID, like for example the UE 855. Yan. So kinakailangan niya pumunta sa ito yung mga cell ID list. So cell ID 39 and 40, okay? And then we have the prefer. Ito yung mga preference yan. So pupunta sasabihin ni ni non-real time rig si UE ID 855 preferred pumunta sa cell ID 39 and 40, and then forbid, no, yung mga cells na to. So siya pupunta dito kay 81, 82, and 83. Okay? And then punta siya kay slice ID 11, and meron siyang QoS ID na 67. Okay, so ganun yung mga type of ano niya, no? Type of traffic steering policy na binibigay niya, no, ni SMO pababa kay ni real time rate. Okay? So ayun yung sample ng ano ng traffic steering. So let me just check if we can open yung ano, no, yung Remedo na ano. Eto, teka lang ha. I'm not sure kung magkakaroon kayo ng open ng ano, kung ma-open nyo 'to, no. So this is a typical example ng traffic steering. So this traffic steering demo of Remedo. So you can also go to Remedo Labs. So marami silang magandang ano diyan. So Remedo Lab is one of the ano, no, developers ng X-apps in terms of the RAN intelligent controller. Okay? So you can see here yung mga different X-app, no? Andito yung mga different cells natin. Okay? So this one is a macro cell. Okay? And this one is a small cell. Ito yung mga maliliit na mga sites natin with small power but high bandwidth. Okay, may small cell ka dyan. And then meron kang small cell, and then meron kang small cell. And then each cell have a different ID as well. So you have, for example, ID 0. Hindi sasabihin ko mga ID, no? Type, macro cell. And then meron kang rate, meron kang band, or if it's 2 gigahertz or the bandwidth of 10 megahertz. And then you can have the ID, small cell, okay? Andiyan yung mga parameters na yan. And then each user, like for example, meron kang user, ito yung ID ng user mo, no? And then what type of service ang ginagamit niya? Like for example, voice UE, okay? And meron tayong ID number, UE number 20, ano yung kanyang type of access, pwede siyang mobile broadband, okay, nagde-data siya, no? And you can see here, for example, when the implementation of X-app in the RAN intelligent controller, you can, for example, we would like to install yung traffic steering, no, or the frequency band selector, traffic steering, or itong QoS based resource allocation. So let's try the traffic steering. So when we look at the traffic steering, okay, so andito siya. So ito yung policy na pinakita ko sa inyo kanina. So the label is default. So ang name niya is default policy lang muna. So cell ID type ID 1, and then preference is default. User type ID 0. Okay? So yung 0 meaning ito yung macro cell. Ito yung macro cell natin kanina, ayan. And then yung cell type ID 1, ito yung mga ID 1 na mga small cells natin. Okay? And yung mga user type, it's either voice or MBB. Okay? So what we will gonna do is we will turn on yung ating machine learning. Okay? Okay? Teka lang. Okay? And anong gusto natin? Gusto natin ba is offload natin yung mga users natin? Okay? And on natin. Naka-default na. Teka lang. Off muna natin siya. And then gusto natin ma-offload. Yan. So ibig sabihin yung mga users natin kapag napupuno yung ibang mga cells, we will offload it. Pupunta natin, idadali natin sa kabilang mga cells. Okay? Ayan. So ito yung distribution ng mga cells ngayon. Okay? So makita nyo, no, yung mga voice UE is here. Okay? And meron tayong mga MBB users. Ito yung mga throughputs nila ngayon. Okay? So when we change itong mga mga strategies na yan, ano? Like for example, when we do the separate, no, voice UE should be associated only to macro. Meaning, all the voice UEs, okay, itong mga voice UEs na to will only be associated to this macro cell. If they want to do a voice call, they should go to this macro cell. Okay? And MBBUE should be associated only to small cells. Okay? So if this is MBB, like for example, ito MBB, dapat nandito siya. No? Kukonekta dyan. Okay? So ganyan yung distribution ng ating separate. When you say offload, yan, ganun din naman sa offload. Ayan. Small cells should avoid associating voice UEs. Itong mga small cells na to, dapat hindi sila kumakain ng ng mga voice call. And small cells should prefer association of MBBs in the UE. Ayan. So ganito yung niya. And then makikita mo yung mga resource allocation at a different cell ID kung sino yung nag-handle sa kanya. Okay? So nandito si MBB UE. Okay? So sa implementation, it is not, syempre, it's not strict, no? Depende sa ARIF environment. Kung talaga hindi, kunyari, masyadong malayo at hindi na makakonect dito sa UE, meron pa rin, syempre, papasok pa rin dito yan sa dito pa rin siya magka-cap na sa UE na yan. So whenever you can also change, no? Kung gusto mong damihan yung UE count, like for example, 45, so you just take time, no? Yan. So automatic, powered by, kapag inon mo yung machine learning, so yung demo will try, no, to decide dun sa policy na gusto mong gawin. Okay, so it will help you decide using the different parameters that it gets from the UE and the network. Like for example, dinamihan ko yung EMBB users ko rin, ano. Yan. And then you can also increase, no, yung ating cell reselection threshold. Kung pupunta ba siya doon o hindi. Ayan. So kung gagawin natin siya mas attractive, yan ang ginagawa natin. So ano yung throughput requirement? So pwede mo itaas. So you can visualize, no. Ay medyo tumaas, no, kasi tinaas natin throughput requirement. So this is just a simulation, a demo how an X-app is being or will work in a near real-time RIC function. Okay? So dito natin parang tinitimpla yung yung distribution ng traffic natin sa ating network. Okay? Okay, so this is the traffic steering application or use case. Okay. Next is the quality of service. Yan. So QoS-based resource optimization. Yung QoS-based resource optimization, when we talk about 5G, we have the different quality of service. No? When you say QoS, it's quality of service. So this is based upon uplink and downlink QoS flow. Okay, and packet data unit session can transfer one or more QoS flow. So bawat session natin have a different QoS flow. So each QoS flow is associated with the QoS flow identifier for 5G. And then all packets belonging to the same PDU session and with the same QFI, okay, receive the same packet handling treatment, especially if they are prioritized equally. So sa 5G, we have three major categories of the QoS flow. We have what we call the guaranteed bitrate or the GBR. We also have the non-guaranteed bitrate or non-GBR. And we also have this delay critical GBR or QoS flow. So typical analogy for the QoS flow is that when we are sharing resources, right? Like for example, nag-drive kayo sa kalsada na papunta kayo ng mall, no? Marami traffic. For example, may concert si Blackpink. So magkakaroon ng traffic 'yan. So congestion sa kalsada. So the road is considered our resources. Like a frequency resource. Physical resources natin. And if a lot of subscribers are utilizing this, magkakaroon tayo ng congestion, traffic, no? Traffic jam. Babagal yung flow ng traffic, right? Are getting me? Are getting my point? So bumabagal na yung ating yung ating throughput. So just to compare with the traffic and sa traffic sa network. And then suddenly, no, kasi ginagamit natin pare-parehas yung kalsada, no. Suddenly, merong ambulansyang dumating. what will happen? Normally happen. What do you think normally will happen? Haharangin nyo ba yan? May sakay yung ambulansya, no? And then, papasok siya sa ano? Giveaway, no? Ayan. Nag-giveaway tayo. Anong ginagawa natin doon? We give space, no? We give that resource, that road resource to the ambulance. Tama? Because meron siyang specific quality of service requirement. Ano yun? Kinakailangan niyang madala yung ano. Tayo, meron tayong QoS na makakauwi naman tayo sa bahay. Okay? Pwede naman tayo madali ng pag-uwi ng bahay. Pero yung QoS na nilalagay natin sa ambulance is way higher than the QoS na kinukuha natin na meron tayo. Are you getting my point? So meaning the ambulance could utilize the resources because it has a higher QoS value. Tayo, nakakagamit pa rin tayo ng resources pero hindi naman tayo sinisipa sa kalsada, di ba? Hindi naman tayo tinatanggal sa kalsada. Nandun pa rin tayo sa kalsada. We're still using the resources but with lower QoS. And then kapag may gumamit na mas mataas na QoS, ibibigay niyo yung resources. So it's just a dynamic allocation of the resources dun sa mga may matataas na QoS. Okay? Are you getting my point on that one? Sa QoS? So ano yung mga 3 categories of QoS? So we have this GBR and the non-GBR and the delay critical GBR, no? So for example, the guaranteed bitrate, okay? So we have this conversational voice, okay? Conversational video. So these are the guaranteed, meaning when you try to make a call, the system will give you this priority level, this packet delay budget, and then this packet error rate. Okay, for you to be able to deliver or to make a good conversational voice. So ito yung ating mga guaranteed bitrate. Okay? If we use for non-GBR, okay, non-GBR, non-guaranteed bitrate, no? So meron tayong mga like for example video buffering. Okay, so once na na-download mo na yan, like for example yung email, okay, so hindi naman yan ganun ka critical. You can send email, you can set chat, you can set FTP, but not like real time katulad ng mga voice call or video streaming. So makikita niyo yung mga default priority niyan, no, medyo matataas. Okay? Unless itong mga mission critical delay sensitive signaling. Okay. So we can set it up sa ating network. And then like for example, itong mga delay critical GBR. So these are the most important and then latency sensitive. Mataas ang requirement ito in terms of the priority level. Okay? And the delay is much less compared sa mga GBR at non-GBR. Because the application like for example is intelligent transport system sa mga ano natin, ano? Sa mga V2X. Okay? So kinakailangan namang instant decision kung titigil o hindi. Unless ano yan, magkakaroon tayo ng disaster. So ito yung mga delay critical GBR. Okay? So sa system meron tayong ganyan. Like for example sa ating network, yung ating QoS is ganito, no? Yan. So, bawat subscriber, we have a specific QoS. And then if we are going for 5G, we belong to different slices. Typical example, like for example, there's a challenge, no? Instantation of RAN sub-slice is prepared by careful planning to understand if the RAN resources will be available to support yung mga sub-slices nung service level specifications natin. And default behavior of RAN is to obtain that shall fulfill slice SLS in most situations. So yun yung pinaka-objective niya. And the scheduler ensures the PRB isolation between slices and usage of the PRB is optimal way to fulfill the SLS for different slices. So when we try to change the scheduler, ito na. When we try to change the scheduler, nasan tong scheduler na to? In which protocol layer? Tandaan niyo pa kung nasaan yung layer na to? Which protocol layer? Nasa PDCP layer ba to? Nasa RLC? Nasa MAC? Nasa physical? Yung scheduler natin. Tingin niya, nasan to? Physical? MAC? Yan, nasa MAC layer. Yung natin, scheduler natin. So anything na kailangan baguhin natin yung, for example, meron tayong carrier aggregation or scheduling ng mga PRB utilization, sa MAC layer tayo pupunta. Okay? So whenever there is a policy coming from the non-real-time rate, ibababa niya kay near real-time rate. Kung uutusan ni near real-time rate, IC distributed unit. Dahil nandun yung MAC layer. Are you getting my point? Okay? So, dahil meron tayong case na kailangan baguhin yung scheduling, no? Kailangan utusan ni real-time rate si MAC layer. Hindi sila PDCP. Kasi hindi naman yun concern sa scheduling ng PRB, ng resources eh. Okay? Ayan. So, ang aim natin is to monitor performance of run slice by SMO. Okay? So, may monitor the SMO yan to understand how often and where the run resources are not enough to fulfill the SLS using the default configuration. So, kailangan malam ni SMO yan. And then, it will provide the QoS-based resource optimization to be used when network is configured to provide like yung preferential QoS for certain UEs. Network is, like for example, the network is configured to support end-to-end slice, no, and has to ensure resource isolation between slices and monitor fulfillment of slice in the service level specification. So the required data para magkaroon tayo ng QoS-based resource optimization is resource consumption in an area. Okay? So gaano na ba congested yung area? Okay? So if run scheduler provides all users needed resources, no? So when high or above the threshold, okay? So kinakailangan yan. And then detailed observability, giving insights in the performance of the specific UEs. Like for example, UE throughput and delay. Yan. So yung mga realization, there is a detecting the run SLS cannot be fulfilled and use the non-real-time rate A1 policies to improve the situation. So may yung current natin ngayon is hindi siya gano'n nag-i-improve, no? Based lang sa QoS. Na may bigyan kayo ng sample. And then non-real-time rate uses additional information from SMO to understand how to utilize A1 policies and how to resolve situation. And the desired default run behavior is configured over O1. Okay, so ito naman typical na natin to nasa architecture. For example, meron tayong isang CCTV camera. Okay? CCTV camera na nakatutok sa isang building. And then, suddenly, itong CCTV camera current situation is transmitting the data to the core, no? To the main frame natin para ma-access natin. Remote camera yan. Okay? Transmitting via 5G network. Getting my current scenario. So meron isang camera connected wirelessly using the 5G network. Tapos meron siyang specific QoS, nasa slice siya ng IoT. Okay? Or nasa slice siya ng EMBB. Depende sa no? Depende sa slice natin kung nasan sila. Okay? So mangyari is nagkaroon ng sunog. So nagkaroon ng emergency, nasunog yung bodega o yung warehouse na binabantayan niya. And then typical na reaction ng mga tao is ilabas yung telepono. Labas yung telepono, i-video at i-upload sa Facebook. Mag-live. Tama? Hindi naman tama, no? Normally, gano'n, no? So, may nasusunog. So, nasa isang cell tayo. Nakakonekta yung 5G sa cell. Tapos, biglang maraming nag-upload ng sunog dun sa area. Same cell. Ano mangyari? There will be congestion. Okay? So, once there is a congestion, ano mangyari dun sa throughput ng camera na nagfi-feed nung video. Eh di babagal 'yon. Tama? So, ang gagawin ng ating ang gagawin ng ating system is babaguhin yung QoS requirement nung ating camera. Okay? Nung UE na 'yon, no? Yung ating UE. And then yung mga QoS nung ating mga nagvi-video is ibababa niya. Are you getting my point? Kasi kinakailangan natin i-prioritize yung video nung nasusunog na na warehouse. Kaya kinakailangan yung transmission nung camera going to the data center should be enough, no? Or should be sufficient. So parang ano yan, nagka-traffic sa network, dumaan yung ambulansya na analogy natin kanina. So yun yung typical example ng QoS-based resource optimization. And then once nag-okay na, nakita na ng network na okay na ulit yung transmission nitong system, nakita ni non-real-time rig na okay na yung mga throughput. So balik na natin ulit sa sa typical na natin, QoS assignment. Okay, so nagiging dynamic yung ating network dahil sa artificial intelligence/machine learning. Dahil yung sa mga inputs na kinakailangan natin, itong mga inputs na to. Okay, so kapag dumadami yung consumption sa area, nakikita niya agad yan. Okay, instant prioritization. Okay, so ito yung ating QoS-based requirement. And then another interesting part is the run sharing. Yan. Run sharing. Narinig niyo na ba yung run sharing? Have you heard about run sharing? So typically we have different type of site sharing models. So we have 4 major site sharing models. Number 1 is site sharing. Okay. Next is passive sharing. And then we have the active sharing. And we have the gateway core network sharing. No? Yeah. Site sharing could be civil infrastructure or backhaul. So meaning, yung typical na ginagawa natin sa ating mga cell site. Okay? So meron kang tower. Okay? Meron kang tower. Andito si Smart. Ito yung equipment ni Smart. Andito yung equipment ni Globe. Okay? And then meron kang antenna ni Smart. And then meron kang antenna ni Globe. Okay? So nakakonekta dito. Ito nakakonekta dito. So ang sinishare lang natin is yung tower. Ang tawag natin dyan is site sharing civil infrastructure. Ito yung ginagawa natin sa mga tower sharing natin. Okay? And then you can also share the backhaul. Okay? So yung transmission natin, okay, yung transmission can be shared. No? Nasa isang transmission lang siya. Yan. So pwedeng ganyan, ano? Yan. Papunta doon sa kabilang site. So ang tawag natin doon is backhaul sharing. And then we also have what we call the passive sharing. Okay? So sa passive sharing naman, ang ginagawa natin, we are sharing the RF path or the antennas. Like for example, meron tayong isang antenna, meron tayong radyo ni Smart, meron tayong radyo ni Globe. So site sharing yan. Ano yan? Antenna sharing yan. Normally, ginagawa natin yan sa mga malls. Ano yung ginagawa natin sa mga malls? Yung mga IBS site natin. Okay? So typical, meron lang simple DAS yan. Okay? May mga DAS system yan. Okay? And then merong combiner dito. And then nandito na yung iba't ibang operator. Nandito si Smart, si Globe, si dito. Kung pwede si dito. Okay? So, RF path sharing naman yan. Or antenna sharing. Next in line is the active sharing. The MORAN or the MORAN. MORAN means, ano sabihin ng MORAN? Kalimutan ko yung MORAN. MORAN is multi-operator core network, and multi-operator radio access network. So later, pag-usapan natin yun. And the gateway core network is sharing of core network. Okay, pero ito bihira ito core network. Okay? So let's move sa illustration ng site sharing. Okay, so these are the site sharing models. So you have the core network, okay, and then you have the RNC, the controller or the node B in terms of the 3G. 3G to, no? And the cell frequency. So typical kapag ka site sharing, different ano pa rin yan, no? Different as infrastructure pa rin yan. For the MORAN or the MORAN, multi-operator radio access network, you are sharing the node B. Okay, and then hinahati lang natin yung frequency. You will use your own frequency. You will use your own frequency. F1 or F2. Pero sa RAN sharing model na MORAN, multi-operator core network, you have different network. You can use one radio, one RRU or one RU, and then you can use only one frequency. Okay, it's either the frequency of the operator 1 or frequency of the operator 2. Ang mangyayari na lang, isahatiin sa core network. No? Na, uy, akin tong subscriber na yan. So, ang tawag natin dyan is multi-operator core network. Okay? So, ito yung typical natin. Ito yung site sharing. So, nag-operator A at operator A and operator B. So, we share the different types of equipment. Pwede naman tayong mag-multiband combining. Ito yung RF path. Okay? So, pwede tayong mag-ganyan. Operator sharing or infrastructure sharing. And ito yung MORAN and MORAN. Okay? Sa MORAN, so we have a different core. Shared yung ating radio or G node B. And then we have different frequency. You can see different frequency, frequency 1 and then frequency 2. In the case of multi-operator core network, we have the same frequency. It's either the frequency of the operator 1 or the frequency of operator 2. For example, meron tayong operator ni Smart. Okay? So Smart, tapos meron tayong operator ng kay Globe. So it's either frequency lahat ni Smart ang gagamitin dito sa MORAN, or kapag kay Globe, frequency lahat ni Globe ang gagamitin. So typical nagkakaroon to ng trade-off or swap. Swap, kalimutan ko yung pinaka-term, no? Swap na arrangement between operators. So give me 3 sites, I will give you 3 sites. Yan. So bigyan mo ako ng 5 sites, sabi ni Globe, bigyan mo rin ako ng 5 sites, sabi ni Smart. Pwedeng ganun yung MORAN. No, to just to balance yung X-deal. Yan, very good. Thank you, Sir LD. Kakaroon ng X-deal. Yan. So bigayan sila, no? MORAN, ginamit yan dati sa sa Smart Sun dati. Nung nagta-transition, yung pag-acquire ni Smart kay Sun. Yan, ginamit yung MORAN. But I'm not sure kung ginagamit ngayon, no, sa Pilipinas yung MORAN. Normally kasi meron tayo mga sites na magkakatabi, di ba? May nakita kang Smart dito, tas katabi niya yung sa tower, no? So Smart to, Smart yan, tas ito Globe naman. Yan. So hindi sila nagkasama, no? So bihira yung MORAN natin dito. Typical, magkahiwalay pa rin yung tower nga eh. Ayaw pa rin magsama ng isang tower. Pero I think meron mga arrangement na ginagawa dyan. Okay? Ayan. Okay. So, sa MORAN, ganito ang itsura ng MORAN. So, meron kang, ito yung typical architecture niyan. So, meron kang core network, transmission, ito yung baseband unit, ito yung remote radio unit, di ba? And then, you have the same frequency. No? So, si operator B ang ginagamit natin. Okay? Yan, pati frequency ni operator B. Ito yung MORAN. So, pwede rin naman operator A. No? Basta site ni operator A. Ganun yan, ano? Pwedeng ganun. Okay? Kapag ka MORAN naman, so you can separate, no? We can use yung ating mga frequencies pa rin. Yan. But you will use the frequency capability nung ating radio. So frequency 1, frequency 2. Pwede yan. As long as pasok sa specifications ng radyo. Okay? So as long as pasok sa power at sa frequency range. Yeah, so you can use that one. So it's an opportunity as well. Like for example, sa mga contractors ng tower sharing, no? If we are going to really implement Open RAN here in the Philippines, not only the tower you can also offer the radio. from the Open RAN vendors, di ba? So you have this tower, you also have the radio access network and the antenna. And then what will the operators will do? Will just rent your radio access network and then just configure the connection going to their respective core network. So magandang business case, di ba? Ayan, so isa yun sa mga use cases na pwedeng gawin sa Open RAN. So what will happen in the MORAN use cases, particularly sa MORAN, no? Yan. Sa MORAN use cases, what will happen in the Open RAN is like this. So you will have a separate SMO for each operator. This is operator A and operator B. And then there will be an interconnection in the NMS. Okay? Different operator yan, ha? And then each operator have their respective non-real-time RIC. Okay? But since the ODU and the OCU, CP, and the ODU can be virtualized, remember the option that was prioritized by the different operators. Since they can virtualize the functionality of the CU and the DU, they could activate it in the shared computing resources. So you can activate your CUCP in the operator A's shared computing resources, and you can also activate ODU, no, sa kanyang shared computing resources. Okay? Pwede rin yung ORU is shared, like what we are doing right now in the MORAN. So what is the benefit of this? You can control. Okay, you can control your own resources in the RU. Okay, previously kasi ngayon hindi. What is happening right now is that, for example, I'm the host operator. You cannot access the KPI. I will not give you access to my KPI, di ba? I will just give you the KPI values na processed na or raw data exported, ibibigay ko sa iyo. But this time, all the functionalities like changing in the specific cell, no, so you can change, you can control because you have your OCU CP and the ODU, and then it is still connected sa iyong separate SMO. Okay, so that's one of the promise or one of the good application ng Open RAN system. So each operator can work independently using a shared network or shared computing resources dahil sa virtualized function na to na pwede mong i-define sa loob ng mga shared computing resources na yan. Okay? Basta mayroon silang interconnection. Okay, so ito yung ating MORAN use cases.